Well, welcome everyone to today's webinar where we are diving into what's new in the AWS Analytics Stack for 2021. Exit Certified is excited to bring you this presentation, and I have the honor of introducing the content expert, Miles Brown. Miles is the Senior Cloud and DevOps Advisor at Tech Data Exit Certified. He has over 20 years of experience in the IT industry across a variety of platforms. Recognized as an AWS Authorized Instructor Champion and a Google Cloud Platform Professional Architect and Instructor, Miles has delivered award-winning authorized IT training for the biggest cloud providers. Before we get started with our presentation, let's cover the functionalities of the session. During the webinar, the audience's microphones will be muted. So if you have a question, please enter them in the chat box at the bottom of your screen. If you enjoy the presentation today and you're interested in learning more about training anywhere with our interactive virtual platform, IMVP, I want to invite you to visit our website and contact us. I encourage you to stick around until the end of the session because I'm announcing a limited time promotion on training with Exit Certified. Last but not least, the session today is being recorded and we'll share it with everyone who registered to be here today. All right, let's get started. Miles, you can take it away.
Thanks, Michelle. And I guess we'll probably be sharing the slides as well, because I've got a lot of hyperlinks on the slides where you can click through and read the announcement, and then from there dive into the documentation or whatever blog entries that they have on that announcement. So welcome everybody. This is going to be about an hour. Hopefully I'll be finished talking at about 45 minutes, and then we have some time for questions. But if you have questions along the way, you can throw them in the chat. I think you can either chat with just panelists, which is basically Michelle and I, or with panelists and attendees. And that way everybody sees your question. Then we don't get the same question 50 times. Might be better to use the panelists and attendees when you ask a question. First off, I work for Exit Certified. Exit Certified is the go-to-market brand of Tech Data. All we do is training. We're partnered with AWS and over 20 other large vendors like IBM and Google and Oracle. But personally, I'm a big data guy. I started off doing a lot of Oracle stuff, taught some classes for Oracle, then moved more into the big data side of things, did a lot of Cloudera, Hadoop work. And then about 7 years ago, I started teaching AWS classes. I used AWS for a few years before that. And, that kind of changed everything for me, going into the cloud. And so my current role is, senior cloud and DevOps advisor. I'm sort of the technical lead for our cloud and DevOps business. And today we're going to look at the AWS Analytics Stack, get a quick overview of it, and then kind of dive into what are some of the newer announcements, both on the streaming and Lambda side of things, then a little bit on storage. We're not going to cover all the things on storage, but storage does affect us in the analytics stack. And then, the data lake ETL stuff. So we're talking about EMR, lake formation, Athena and Glue, and then finally with the data warehousing side of things with Redshift. And so most of these announcements are from the very end of 2020. So every year at the end of November, beginning of December, AWS has their annual conference called reInvent. And this year it was virtual and it was 3 weeks long. And they save up a lot of new announcements, a lot of new features for that time of year. Although some of the announcements I'll talk about kind of predated that a little bit. But I just want to kind of get you, what's the current state of the analytics stack? But let's start with a quick overview of it. So if we sort of rewind the clock, say 6 years ago, this was sort of the state of the art in the analytics stack in AWS. Essentially, most people were dropping files into S3 and then doing batch processing using Hadoop. And once EMR came out, that made it very easy for people to provision and run a Hadoop cluster in the cloud. And you didn't have to fiddle around with going and launching individual EC2 instances and installing, Hive and Spark and whatever other Hadoop projects you needed. They made it very easy to say, hey, I want a cluster of 100 machines that look like this. And if one died, it got replaced. And so EMR was, really our state-of-the-art kind of analytics platform. And so we would use it to do, largely ETL jobs. We would take the raw data from some set of S3 buckets, go and process it, and then we would have a finished product, which generally people would drop into S3. And then if there was a subset of that we thought would make sense for a data warehouse, we would pull it out of there and copy it into Amazon Redshift. And Redshift is our sort of flagship data warehouse product. It's very much a competitor of things like IBM Netezza and Oracle Exadata and Teradata, any of those kind of enterprise data warehouses. And so you would only put the data that you know that you need, fast SQL access to this large data. And then you would attach whatever BI tool you wanted to it. Most people will use a commercial product like Tableau or Cognos or who knows, there's about 40 or 50 different, Domo, Click, the list goes on. But AWS did throw their hat in the ring and they built a cloud-powered BI tool called Quicksight. Now, when it first came out, they're really big on the minimal viable product at AWS and underline that minimal, right? So when Quicksight first came out, it looked a lot like Tableau, but it was missing most of the features. And so people, when they look at things that come out from AWS, they say, oh no, that's a piece of garbage, I don't want to use it. But if you wait a little bit, they'll add and add and add to it. And AWS really is customer focused, customer obsessed, they like to say, and they will, anybody who signs up for the preview of a new service, they will, pester you with questions about, hey, what did you like about it? What else do you want to see in it? And you'll see that product, mature right in front of your eyes. And so Quicksight is a lot better than it was when it first came out. Right? But, again, if you don't want to use that, you want to use some other tool, fine. Right? And so this is sort of how analytics looked, say, 6 years ago, right? The biggest change probably in that 6 years is that instead of doing just batch processing, we're doing a lot more stream processing. So instead of just dropping files periodically into S3, we might be grabbing data from various data sources, pulling it in through streaming or through messaging or something, maybe into S3 or maybe into other, maybe processing it in other ways. But now you see that we got a lot of options, right? When it comes to stream processing, Kafka came out, a long time ago, and it's very, very popular for building these sort of a place to hold data that comes in really fast from maybe lots of different data sources, maybe little bits of data that's coming in really fast in a continuous fashion, and then processing it, maybe with different consumers and different timelines. This app needs to grab all that data every 10 milliseconds. This one needs to grab it every 10 minutes. And this one needs to grab it every 10 hours, right? And so we hold that data for a period of time. Well, AWS decided to build their own kind of flavor of this sort of streaming, and they called it Kinesis. And now Kinesis actually is composed of like 4 different sub-services, if you want to think of it that way. But eventually, some people complained. They said, I'm moving to the cloud, and I've got all this code written according to Kafka. I don't want to have to go and rip out all that code and now have everything talk to Kinesis instead. Can you not support Kafka for me? And so it turns out they did. They said, okay, yeah, we've got managed streams for Kafka now. And so that's sort of, if your code is all written according to Kafka and you want to use that, then you can. But Kinesis sort of integrates better with all the other AWS services because it was, built homegrown. SQS has been around. I mean, this predates AWS really. This came out in 2004, whereas EC2 and S3 and what we normally think of as the basics of AWS didn't come out till 2006. But SQS is our simple queuing service. If you just have sort of an event, hey, I want to drop this message, and then somebody will pick it up later. That's what SQS is. But a lot of people, again, sort of complained and said, well, that's great, but my existing app that I'm moving to the cloud, it's got all kinds of code not written according to SQS, but according to, a very popular open source messaging queue called Apache ActiveMQ, right? It was a very popular open source product. So, hey, can you help us with that? And that's what Amazon MQ is, right? So we have all these different options if we want to move data, little bits of data quickly. Now, one of the biggest changes that we've seen in that last 6 years is that AWS is really starting to push their serverless concepts, right? So instead of, every time you need some compute, having to provision a virtual machine and run some code that lives on there, and then have to be responsible for that whole virtual machine and the operating system and the file system and everything else, and dealing with Linux or, whatever. They came up with all kinds of serverless options, things like Lambda. AWS Lambda is, hey, I'm a developer, I wrote some code, I can figure what's the event that triggers that code to run, so that's serverless compute. Well, if we look in here, where is the administrative burden? Well, if you look at Redshift, if I just want SQL access to my big data, do I really need to move it out of S3 into Redshift? So that's a copy of data, takes time to do that. And Redshift is an enterprise data warehouse. It does take some administration. It's not as bad as running, Teradata on a bunch of physical machines in your data center, but it does have some administrative burden, right? And so once they came up with a way to do SQL on S3, namely Athena, some people opted for that instead and say, well, hey, if I took my raw data that was dropped into this S3 bucket and I did some ETL on it, and the result of that was well-structured files in S3 that maybe are set up in a columnar format and using compression and all the good things that enterprise data warehouses do, well, then why couldn't I run SQL directly on that? And that's what Athena allows us to do. We can query those aggregated data sets. And instead of moving the data into another place and then having to manage that place, now I can just run my SQL queries directly on this well-structured data in S3, right? And for some people, that is their data warehouse. This is the model that Netflix kind of popularized. They've got 20 petabyte data warehouse. It's just a bunch of files in S3. Now, their setup sort of predated Athena. They were running an EMR cluster with Presto, right? And so they would pay by the hour for however many machines would make up that cluster. But all that EMR cluster was set up to do was to run Presto, which allowed us this SQL on S3. Well, Athena just says, hey, you don't even have to run that EMR cluster. We'll take care of it for you. And instead of paying by the hour for however many machines make up that cluster, you're just paying per query. Right? And so we can query that well-structured data. We can even do ad hoc queries on our raw data, right? And so what this raw data in S3 ends up being is what we call a data lake, right? It's the data from wherever it came from in its natural format, dropped in there. It's not, we haven't processed it at all, so we haven't lost any context of anything. Now, ad hoc querying that, it might not be well formatted, it might not be well compressed or anything, so we're not going to get really good high performing queries on it, but it does give me that option if I'm a data scientist and I'm just kind of looking at the data and figuring out what does this data mean. So Athena was one of our big serverless changes over the years. The other big change was, well, what about this EMR cluster that's doing the ETL? Can we do that in a serverless way? And of course the answer is yes. That's what Amazon Glue is. So it could be used to perform serverless ETL. So again, it's kind of that idea where there is still a Hadoop cluster somewhere, but I'm not managing it. Amazon is. And I'm just paying for, my usage of it. Hey, how much time does it take to run these jobs kind of thing. And so that's what Glue is. The underpinnings of it is it's all Spark running on EMR somewhere, but it's not my concern about the cluster. And they can actually generate some of the Spark code, and then as a developer, using either Python or Scala, I'll go and tweak what comes out of that, and that's where I really do my ETL processing. So that's what the current sort of stack looks like. Now, when we talk about the analytics stack, we don't get too much into the machine learning side of things, because in AWS, that's kind of considered its own whole category, and now we see a lot of different things, although they are starting to bleed together. We're going to see that there's some machine learning now in Redshift, some in Quicksight, and we can certainly run machine learning frameworks on EMR, right? So they start to bleed together a little bit, but I'm going to try and keep this largely machine learning free because this is enough of a stack to handle on its own. So let's start with the sort of ingestion of data, around Kinesis. What are some of the new things that came in there? And we'll actually tack in a little bit of the new on Lambda because that comes up as well. So the big thing here, Kinesis, what does it do? It holds streaming data collected from various data sources for a period of time. And then it allows multiple consumers to come in independently, maybe on their own timelines, and grab that data. Traditionally, a Kinesis data stream, and by default still, it holds data for 24 hours. Now, if you want, you can add extended retention. And so traditionally that was up to 7 days. Now, it's pretty costly. Every hour over 24 hours of retention costs you some money, right? But, that 7 days was the maximum time. And so what most people would have to do is basically, build one consumer that all it does is just says, hey, grab all the data every 12 hours or something, grab it, dedupe it, aggregate it, and throw it into S3. Because I don't want to lose any of the data, right? But typically the stream only holds it for a period of time, and different consumers will come and grab it and process it. But one of them would probably grab all the data, put it in S3. Now we have something called long-term retention that you can turn on, and it can hold the data for up to a year. Right? Now you pay to retrieve the data that's older than 7 days. So there's an extra fee in there. And you also pay for that extra retention. You pay basically 2.3 cents per gig. Per month. So it's basically like S3 pricing. So, that is kind of what it's doing under the covers. So that's sort of a new thing. Another aspect of Kinesis is something called Kinesis Analytics. And what this was when they first built Kinesis streams, like they're very much like Kafka streams, then they made something called Firehose, which made it easy to build a stream that its only job was to aggregate data to write to S3 or to Redshift or a few other places. You weren't going to have a bunch of different consumers. You just had one consumer that was sort of aggregating data based on size or time, and then writing it out to S3. So if you have either of those kinds of streams, what Kinesis Analytics allowed us to do was to use regular SQL style processing of the data going through one of those streams. So assuming the data in that stream was sort of well structured, like maybe it's a tab delimited or it's JSON data or something where I could layer a create table command on top. I could say, hey, that looks like a table. I can run queries. If I ran the same query 5 seconds later, there'd be new data in and some of the data aged out, right? So I could look at a snapshot, or I could say, hey, run this query continuously and take the result and put that out to a new stream. So this was what they called Kinesis Analytics, but it was really all SQL style processing. Recently, what they've added was it now uses Apache Flink under the covers, which is sort of a stream processing framework, a little like Spark Streaming. And it creates simple processing options in Java and Scala, and Python's coming soon. And then after that, who knows, maybe more languages. And it allows Flink to work on data, to work on data, not just in Kinesis streams, but it actually opens it up. So if I have that Kafka, that managed Kafka or Elasticsearch or S3 or whatever, I can work on that data. And what it really does is it says, hey, we can make running Flink really easy for you. So as data is going through a stream, I can build these processes on it, not just with SQL, but with real programming languages. And it supports Flink 1.11 and also something called the Flink dashboard. So, like I said, all these underlines, these are all hyperlinks. So if I click on this Apache Flink under the covers, it'll take you to the announcement. So this was back in October, they introduced the idea of Flink, and then they added new versions and stuff on top of it. And so this is sort of the what's new. And then from there, you can click through in to read more about Kinesis on Apache Flink or go into the developer guide. So all those hyperlinks, like I said, will be available. We're going to share a PDF with you if you want to click through any of them and delve into it. By the way, if you're just trying to keep abreast of what's new in AWS, that's what I do. I go to that AWSamazon.com/new. I go there probably once a week, and I just kind of look through the list. There's usually 40 things in a week. I kind of skim it and look, is there anything of interest to me? Click through, read the announcement. If it piques my interest, then I click through into maybe the blog entry that explains how it works, so on. So that's a little bit about Kinesis. Not a lot new in Kinesis, but that's kind of the big major thing. In Lambda, there's a bunch of new things in Lambda. The idea of Lambda, we said, was it's basically a unit of serverless compute. So you write a Lambda function in one of a bunch of different languages now. And then as a developer, you say, here's the event that triggers this Lambda function. So it might be when somebody uploads data to this S3 bucket, that's an event. Or when a new message comes into Kinesis, or to a DynamoDB stream, right? And over the years, they've added more sort of events, and now they allow for some things like sum, average count, and other simple analytics functions over a contiguous time window, up to 15 minutes. So this is sort of an interesting idea. They also have checkpointing for Kinesis and DynamoDB streams, so that if there is an error, we can figure out, well, which data have we processed already and which haven't we? And so we can minimize the duplicate processing after failures. There's new event sources. So either Kafka self-managed, my own Kafka running on a bunch of EC2 instances, or the MSK. Those can be events that trigger Lambda functions. Amazon MQ, so just like SQS, somebody sends a message to a queue, hey, that's an event, go call Lambda. We can do the same with Amazon MQ. Now, the real big changes to Lambda are increasing where it can be used. It used to be that when you set up the Lambda function, you write the code as a developer, you configure what's the event that causes it to fire, and then the only thing you have to think about the infrastructure is how much RAM do I want to dedicate for this thing to use, right? And then they would give you a commensurate amount of CPU. So the more RAM, they'd give you more CPU. And so that was really the only metric we had to think about, the only knob that we turned as far as operations go on Lambda. But it maxed out at 3 gig of RAM. Now you can go up to 10 gig. Right? And basically, under the covers, it scales up to like 6 virtual CPU. Right? And it used to be that, in the old days, it was like, hey, it had to finish in, 3 minutes, and then they upped it to 15 minutes. That hasn't changed. It's still 15 minutes, but it was billed in 100 millisecond increments. So if my Lambda function ran, like the event occurs within, a millisecond or two, it says, hey, go and launch this code, right? And that code ran for 340 milliseconds, you'd be charged for 400 milliseconds. There was 100 millisecond increments. Now they've changed that granularity down to just 1 millisecond. So, they've made Lambda probably a little bit cheaper for most people. But probably the biggest change to Lambda is this one. Instead of that idea where we say, hey, here's the available languages to you, Java, Python. Oh, you like Python? Well, you can use 2.7 or 3.6. There was only a few different options. Now, instead of choosing one of those languages, you could say, hey, I've got a Docker container, and I just want you to use that. And so they provide you with various containers that you can start with this Docker file and then add whatever you want and install whatever languages. And so it's, you basically always knew that this Lambda function was running in some sort of container. Now they're just making it explicit, and you can provide the actual Docker file. And so this really opens up languages and things like that. And now they've added something called CloudWatch Lambda Insights. So you get nice automated dashboards summarizing the performance of the health of those functions. So in addition to the regular kind of, very rudimentary diagrams for CloudWatch, we now have this Lambda Insights. You have to turn it on. It costs some money though, but it provides you with some interesting stuff. All right, moving right along. Storage is a huge area. There's lots of new changes in storage all the time, dropping prices, all kinds of things. So we're going to concentrate on just a few of the big changes here. Starting with EBS, that's our elastic block storage. We use that for, hey, if you launch any EC2 instance and you want a root volume or any other kind of volumes, disk drives, if you want to think of it that way, EBS is that. And also we use it in EMR. When you set up a Hadoop cluster, you say, hey, what do the disks look like? Well, traditionally we had two types of EBS volumes, either the sort of old school, magnetic spinny disks, the platters, we call those hard disk drives, and the newer sort of solid state drives, which are much better for random read-write access, but are more expensive and don't get quite as large. So that hasn't changed. We still have those two types. When we look at the old hard disks, they've dropped the prices by 40% for the cold hard disks, so what we call SC1 instances. On the solid state drive side, they've updated. We had something called GP2 instances, the general purpose ones. Now we have a GP3, and they are basically 20% lower price. And otherwise, they have the same sort of capabilities. It's almost a no-brainer that you should go and switch all your GP2s to GP3s. And they have a nice, easy way to do it, and you'll just save money right away. So that's a big one. When it comes to, so that's general purpose. When it comes to, where you need a lot of read and write back and forth to the disk, you need a high number of IOPS, what we call IO operations per second. We have a new type of provisioned IOPS volume called IO2. We had the IO1s. The IO2s just came out. They have 100 times better durability. So they've got like 5 nines of durability rather than 3 nines of durability, and 10 times higher IOPS to storage ratio. Right? So big changes there. Right? So, that's one of the things you learn about AWS pretty quickly. When you build your architecture, you don't just say, well, that's it forever, right? Because every year, AWS comes out with new instance types. If nothing else, you need to keep an eye on that, because you might be using something. Every year, there's new instance types. Not every instance type gets an upgrade, but some of them do. And same thing with disk types, where you say, oh, if I switch to the new one, I generally get either better price or better performance. Either way, it's a better price to performance ratio than the old versions, right? And so you need to keep an eye on that. So that's a little bit about EBS. When it comes to S3, we've always, well, not always, but for a long time, we've had this concept of replication, where you set up an S3 bucket, say in Northern Virginia, and you say, hey, whatever gets written to that bucket, I don't want to put all my eggs in one basket. What if something happens in that region? Now that's rare, right? But if I needed a disaster recovery site in some other region, so say in Singapore or somewhere, we could set up another bucket over there and set up what we call cross-region replication. So anything that gets written here will asynchronously be written across to the other region into that bucket. Now, there is a charge, we're going to be storing the thing twice, so we're paying twice the storage. Also, there's a data transfer charge, moving data from one region to another, usually around 2 cents per gig to move that data around. But you could only do to one place. Now we have the idea of multiple destination buckets for replication. And also they added, right there in December, this concept of two-way replication. So I could say, hey, I need these two buckets to be in sync. So whether I'm writing to this one or writing to that one, I need to, see it across. The biggest change in storage, I would say, is this last one. S3 now has strong read after write consistency for all applications, right? So S3, it's very durable, right? When I say upload a file to S3, they say it's got 11 nines of durability. That means if I upload a file today, the chances of Amazon losing it in the next year is 0.000000001, right? And you're like, how do they come up with that number? Well, it's the idea that they're copying that data to 3 different locations, right? So 3 different data centers, and at least one of them is in a different availability zone. So many miles away. So what we're looking at is, hey, for Amazon to lose your file in S3, something really bad has to happen, that these 3 different data centers all burn to the ground and they're geographically separated, right? But that kind of comes at a cost, right? And so it's traditionally been what we call an eventual consistency model. So when I write my file and it comes back and says, thanks, it's written, if somebody goes and tries to read that file right away, they might not see the change, right? So especially when I'm uploading a new version of it, they might see the old version for a second or maybe 2. And that's sort of an eventual consistency thing. If you're used to NoSQL databases, you might be used to that concept, but it does cause us problems in data lakes and lots of places where I've got different people trying to look at the same data. And even with Hadoop, where I use S3 and I have, say, like an old school map reduce, like the mappers are writing out to S3 and then the reducers come to read and they say, wait a minute, I don't see all the files here. Like we would have to use something called EMRFS consistent view, where it would say, hey, when I write out these files, let's keep a list of what are all the files, and then the reader doesn't go until it sees them all. And once it sees them all, then it can go and do its thing, right? So there was always like a little bit of handling we had to deal with because S3 was not fully consistent, and now it is, right? And so this is a huge change, changes lots of things in AWS. But especially for us in the Hadoop world, EMR, we don't have to deal with any of this anymore. And so that's good. So speaking of data lakes, let's jump into those services that are typically used around that. We'll start with EMR, which is sort of our managed Hadoop service. Then we'll talk about lake formation, Athena, and Glue. So EMR, I guess originally it stood for Elastic MapReduce. I'm sure they're kicking themselves because that name doesn't ring, too well with people these days. Obviously, MapReduce was sort of the early days of Hadoop, and then Spark really supplanted that as the main batch processing model and streaming model as well. And so maybe they should have called it Elastic Hadoop or something like that, would have worked out better. But traditionally, when you would go to launch one of these Hadoop clusters, you would tell them, hey, what kind of instances to use for the master, what kind of instances to use for the slave machines, and then they would go and provision it. You would just check a few checkboxes. I want to use Spark, I want to use Hive, I want to use Presto, whatever, and then it would go and install all that stuff for you. And if one of the machines died, it would replace it, right? But it was launching EC2 instances. And if you went to your EC2 console, you would see those instances. And you could possibly mess with them, although there was ways to sort of lock that down maybe if you needed to. One of the things that they've added, I don't know how useful this is to most people, but they now have a deployment option. When you launch EMR, you can launch it into EKS, which is the Elastic Kubernetes service. Now, this is really, Kubernetes is making its way into lots of places. It's starting to make its way into people's analytics stacks. Although, when all the customers I talk to, the analytics group is sort of like, yeah, we're a Kubernetes shop, but like not at the analytics part, right? It is starting to creep in. I think it's for this. If you're an existing EKS customer and you've been using Kubernetes for all your applications, and you say, hey, I do want to do this one sort of Spark workload, and everything else we do is based on Kubernetes, I don't want to have to go launch a bunch of EC2 instances for an EMR cluster when that's not normally how we do things. And so it just lets me run EMR, those Spark workloads right alongside my other Kubernetes apps in the same infrastructure, right? So that's a minor change for certain kinds of customers, right? They added a new IDE this past year for data scientists and data engineers called EMR Studio. It's just a nice way to provide these Jupyter notebooks with tools like Spark UI and Yarn Timeline Service, just to make it easy to debug those sort of like Hadoop workloads. But also it's got nice single sign-on with corporate credentials. So instead of having to like give people AWS credentials and go into the management console and work through that, we can sort of just give them this other EMR Studio. And it's a nice way to do that. One of the things that's one of the new things in EMR is that it will now integrate nicely with lake formation. If you're not familiar with lake formation, let me just give you the 30,000 foot view there. It's becoming very popular for people to build data lakes, right? That's been a buzzword for the past, say, 4 years. It's been a big buzzword. And in AWS, usually that means, hey, here's some S3 buckets, drop all your raw data in there, and then we'll go and grab data from there and do some processing in various ways or whatever. But this is where the data lives. Now, of course, it's pretty quick that a data lake will become a data swamp where you just have data, unregulated data. You don't know where it came from. You don't know who's allowed to look at it, right? So along with just an S3 bucket, you need metadata to keep track of where did the data come from, who's allowed to look at it, what's the lineage of it, right? All that kind of stuff. And some sort of way to search it nicely to find the data you need. And a lot of the problems from data lakes on S3 came from the problem of permissions, because when you go to process it with Athena or Glue or maybe EMR or wherever, you've got like, we got to find the data, but what about the permissions? Does in Spark, am I allowed to look at this? In Hive, am I allowed to look at it? In Athena, am I allowed to look at it? And then at a lower level, you've got like actual files in S3. So you've got this sort of metadata level where we're accessing the data through different processing. And then you've got the actual files in S3, and you say, well, hey, I might not be allowed to look at it through Athena, but I still have access to just go grab those files out of S3. That doesn't make sense, right? So lake formation was a way to help you build, secure, and manage data in an S3 data lake. And at first, it was really just a way to simplify setting it up, and more importantly, setting up the permissions on the data in S3 versus Athena and Glue. Right? And the piece that they were sort of missing was the EMR integration, so that my Spark applications have that fine-grained access control that is determined by lake formation and not by file access in S3. So they finally kind of closed the loop on that. And so lake formation now really does provide what it promised originally. And then they went further, and just about a month ago, they introduced some new features in preview still. So preview means, it's not available for everybody. You got to go sign up for the preview. They have this concept of row-level security and ACID transactions on S3 tables. And again, they're enforcing it, at lake formation level. That means I don't care whether you're coming in through Athena or through some Glue ETL job or through a Spark application in EMR, we're going to enforce these transactions at this level of, hey, the data lake. Right? So that's, I think we're going to see lake formation turns into a real data lake product and not just a way to help us with permissions. That looks to be the direction they're going with it. Not quite there yet. Well, in preview. Athena, I mentioned earlier, is this serverless option allows you to query data directly in S3 using ANSI standard SQL. Now, under the covers, it's really using Presto on an EMR cluster that's managed by somebody else. S3 traditionally was used mostly in an immutable way. People would drop files into S3, and then your EMR job or whatever would go grab that data, read it, process it, and write out new files. And so we weren't changing files. We were always processing it and writing out new files. Eventually, people started to run into problems where they said, well, if I'm going to use S3 for my data lake, at some point, you've got like things like GDPR, where somebody says, hey, I want you to delete all your data on me. So we have to go and delete single rows out of files in S3, right? And we have to be able to, maybe insert a single row or update a row or delete a single row. And so they made a project called Apache Hudi. And it was a way to allow for easy upsert support in these EMR workloads and on S3. Well, one of the latest changes is that now you can read those sort of query those read optimized views of an Apache Hudi data set in S3 from Athena. Right? But that idea of Apache Hudi is making its way through all of this data lake stuff, it turns out. And the other thing that they did with Athena is they said, well, this is great, right? It's traditionally been about querying data in S3, well-structured data in S3. Well, now they say, well, let's open it up, right? We're using Presto. Presto allows you to do queries on S3, but that's not where Presto ends. It's a general purpose query engine. It can query anything with a JDBC driver, right? And so they added on all kinds of options now. So any relational database, non-relational custom data sources, I can do it all from Athena now. Right? Now, I think that this all requires the new version of the engine, so engine version 2. And so that's now generally available. It's got all kinds of performance enhancements. They added some new geospatial functions. The concept of nested schemas is allowed. Federated queries, where I can run a query that's spanning across, I've got like well-structured files, like a table in S3, but also in this RDS Postgres table. And I can run queries that span and join tables from various places. So it's very interesting. Really, they're opening up the power of that Presto engine in Athena and giving it to us. Right? So that's a big change in Athena, and that's fairly new. So you'll see it if you go to the management console. You'll see if you try and add a new data source, it might force you to go and switch to engine 2. Right? We talk about Athena, we talk about Glue, right? So Glue is that idea of serverless ETL. You don't need to provision and run an EMR cluster, right? They're taking care of that for you, and you'll pay for, how much compute your ETL job takes and how long, right? It also has the ability to go and run these crawlers and look at all your different data sources and build a data catalog out of it. And then that data catalog is basically a metadata repository for things like Athena and Presto and Hive and anything where I need to be able to access that. Well, they've added new Glue crawlers. They support Amazon Document DB, which is sort of like Amazon's way of saying, hey, if you had a bunch of code using MongoDB on-prem and you want to move it to the cloud and you want to manage MongoDB, well, we don't have, you can run MongoDB on a bunch of EC2 instances, self-managed yourself, right? Or you could use Amazon Document DB. They're not telling us that it's exactly MongoDB, but the API is compliant with MongoDB. So it's a drop-in replacement for it. Well, now we can crawl either Amazon Document DB or even self-managed MongoDB running in the cloud. It also now supports not just batch ETL, but streaming ETL jobs. So you can set up a Glue job that basically, under the covers, is ingesting data continuously from Kinesis or from Kafka, and running this Glue job sort of in a continuous way. And a couple of other changes in Glue, a lot of changes in Glue. They introduced a new visual interface called AWS Glue Studio, makes it easy to kind of set up these jobs. It'll even do some really basic transformations, like visually, you say, hey, connect this to this, and it'll figure out what the transformation is. So it might save you a little bit of code. But really, it's about giving you a nice visual tool for building these jobs. The concept of materialized views is one where, if you had queries that had to grab data from multiple data sources, you could set up now with Elastic Glue, Glue Elastic Views. It's now in preview, but you could set up a materialized view that combines this data from different places, replicates it a bit, and then you can run your query again and again on that. So that's sort of a new preview thing. And the last big change in Glue is the addition of this thing called AWS Glue Data Brew. And again, it's another visual data preparation tool. It's a little different than Glue Studio. But what it does is it says, a lot of what people are doing with ETL is they're cleaning up data, but they're grabbing data, they're saying, throw away anomalies, change this date format to this date format, little cosmetic changes to grab data from different data sources, get them all into one canonical model, and then we're going to go in, maybe build, SageMaker or something like that, go and build machine learning programs based on that. And so if that's all you're using Glue to do is clean and normalize your data, and you don't want to write code to do it, Data Brew can do that. It's got over 250 pre-built transformations for things like filtering anomalies, standardizing formats, all kinds of stuff like that. And now you can kick it off from an AWS step function. So this can be part of your bigger series of steps of things to do. And it can even integrate with third-party data sets using AWS Data Exchange. So if you have some company that's providing some data set that you pay for, we can easily grab that, pull that in with Data Brew, marry it with my own data, and then go and build out whatever applications we're going to build from that. Okay. All right, the last piece, which is good, we're at 1246. The last piece here is on the data warehousing side. So I'm going to talk a little bit about Redshift, traditionally, and what it's starting to look like now. Okay. So it starts with traditionally. Now, traditionally, it's sort of an MPP architecture, massively parallel processing. So we had one leader node and then a number of compute nodes between 2 and 128. Right. And, as an Redshift administrator, I'd say what kind and how many compute nodes, and that would determine how much data can we store. And the leader node acts a lot like a regular relational database, right? It's where the SQL clients would connect through JDBC or ODBC, and they would submit their job, their query, and it would go and it would parse that query, figure out permissions. Are you allowed to query these tables? Yes, okay. It would build an execution plan, and then it wouldn't run it because the data doesn't live on the leader node. Instead, it would basically generate some C++ code, compile that, and then pass that off to the compute nodes. So the smarts were all in the leader node. The compute nodes are relatively stupid. All they do is they say, I get compiled code and I run that code, and it reads the data that I store in my local storage on these compute nodes. Right? So the compute nodes have local columnar storage. They execute the queries in parallel. And we can load the data directly into the compute nodes from, say, something like S3, but it is fault tolerant. If one of these compute nodes goes down, it's not like we've lost all the data on those local machine because the data gets, copied to other machines as well. And so this is traditionally how Redshift ran, right? And the biggest change came out about a little over a year ago. December 2019, Redshift introduced a new type of node. So traditionally, the compute nodes, there was one type that was, traditional magnetic spinny disks, hard disks, and one that was solid state drives, right? They introduced a new one called the RA3s, and they're built on the AWS Nitro system, high bandwidth networking, and they had the compute nodes, but they also had this managed storage layer. So we had these large, high performance solid state drives in the compute nodes, and they would be local caches of data. But the data is persistently stored and scaled in this managed storage layer that could scale up to 8 petabytes. And so the data would be sort of passed back and forth, automatically moved between the local cache and the managed storage based on machine learning algorithms involving data block temperature, data block usage, or workload patterns. But you just pay for storage, however much you're storing, right? And they'll move it back and forth kind of thing. And so this idea of sort of separating this and using the compute nodes for compute and the managed storage really for storage, although the compute nodes did have some local caching, is an interesting one. Now, when the RA3s came out, they had 2 sizes, really big and really, really big, right? And so it was a bit of a problem if you just wanted to learn how it worked. It was expensive just to play with it. Or if you had sort of small to medium workloads, you had to pay for these really big, nodes. And so that was a bit of a problem. But in the future of Redshift, really this idea of the data warehouse and the data lake, they seem to be getting closer and closer together, right? And they both have this concept of separating the storage from the compute, right? Because it turns out that storage needs seem to really outpace our processing needs, right? Amazon identified this sort of balance of system problem where our solid state drive bandwidth has increased by 12 times since 2012, but the streaming CPU bandwidth has only doubled because of bottlenecks at the internal bus. I don't want to get low level, but this idea is maybe if we could do less at the compute cluster and push it down a little bit. So a year ago, they introduced the concept of something called AQUA, Advanced Query Accelerator for Redshift. And it's built on that managed storage concept of RA3 nodes, adding a distributed custom hardware accelerated cache. And so you would have your compute nodes with that local storage. And when you had a query, they could push some of the query down into this AQUA layer. And, it's currently in preview. So in December 2019, they introduced this concept. In December 2020, they introduced it again. And they said, hey, it's in preview still, but it's coming really soon. So now it's like, hey, this is something you should really think about, because it'll get you up to 10 times performance due to offloading certain operations, encryption, compression, filtering, certain aggregation functions. We can push those down into that managed storage layer, right? And so really it's still just in preview, but they made an announcement, a big announcement again this year saying, hey, it's really coming soon. Right? It is in preview mode. You can go in and try and join the preview. I don't know how many more people they're taking into the preview. I think that I asked for it and then never got it, so who knows. But like I said, RA3 nodes, when they were introduced, they had two pretty big sizes. Now there's an RA3 XL Plus. So if we go and look at that, actually, if I just go to the Redshift pricing page, this is probably the easiest way to see it. So you'll see that, traditionally we had, like, for the dense compute and the dense storage was like the spinny disks, the hard disks, and the dense compute was the solid state drives. There's usually a small one and a large one. The small one's like less than $1 an hour, and then the large one's pretty expensive. And so the RA Plus, well, it is just over $1 an hour to play with that one, whereas the other ones are quite expensive. Right. So this gives you an option for, learning about RA3s and then managed storage nodes, and also running smaller workloads using it. Now, again, you can still have many of those. Like, if you got a really small workload, you're not going to use Redshift at all. Right? You don't need a data warehouse if you don't have big data. But it gives you an option for growing at a smaller pace. For all RA3 clusters, one of the new announcements, you can now move your cluster from one AZ to another really easily, because that managed storage layer is not storing the data in one AZ, it's storing it like S3, across multiple AZs at the region level. So if you've got this cluster running, you say, hey, now I want to run the cluster over here, it's really easy to move it. And in fact, they tweaked it so that even the JDBC and ODBC drivers, like that endpoint that I use, doesn't change just because it moved from one place to another. So that certainly helps us with high availability, where these things used to have to be just in one AZ. And every once in a while, AWS loses an availability zone. Something physically happens and that set of data centers is not available. And so this kind of gets us around that. We can easily move it, and we're not going to lose our data because the data's at the region level. They now support scheduling of SQL queries through something called AWS Event Bridge. If you're using Event Bridge, this will be of interest to you. If you're not, then I wouldn't worry too much about that one. Redshift now allows you to use a Lambda function as a user-defined function. It used to be just internally you could build UDFs. Now it could be a Lambda function. Right? And so that allows you, from the Lambda function, I can go and call third-party web services. So when they introduced it, they sort of introduced it with a blog entry where they kind of talked about the idea of using it for tokenization. So as people put data into Redshift, you can go and call a Lambda function that says, hey, I've got some personal data here. I've got, I don't know, social security numbers or something, something that needs to be obfuscated. I can go and use some third-party tool to do that, or if I want to talk to something like DynamoDB or something like, I can't do that from inside the regular UDFs inside Redshift. Now I can call a Lambda function to do it. Now, there's going to be an extra expense you're paying per millisecond that Lambda function runs. When it comes to the drivers, they just open source the JDBC and Python drivers for Redshift. So traditionally, like Redshift is built on top of Postgres. So you could always use the Postgres drivers to talk to Redshift. And they said, we intend to continue to support those, but they're not nearly as fast as the Redshift drivers that you should be using. But the Redshift drivers weren't open source. So if I had to put those into some product, and that might change what kind of licenses I could use, or if I had some third-party tool, it wasn't easy to introduce those. Now they've open sourced those ones, so you don't even have to use the Postgres ones. I can use the highly performant ones but I can use them in an open source way. Redshift introduced materialized views in early 2020, that idea where if I had a complex query that was going to be run again and again and again, so think like dashboards, right? You've got some dashboard and you've got all kinds of employees that bring up that dashboard every morning, right? You're going to run the same query again and again. If it's a complex query that grabs data from different places, we might be better off to build a view. Simplifies the query, but if I make it a materialized view, then I've got the data in there and I can hold that data. And so they came up with it, I think around May 2020, and then in December, they added this idea of automatic refresh and rewrite capabilities. So you can say, hey, yeah, I want you to refresh this query that builds this materialized view every 5 minutes, 10 minutes, whatever, so that we don't have stale data in that view. It really makes it a lot easier to administrate these. Right? So on the BI tool side, this really comes in handy. And then there's a couple of features in preview for Redshift. One is support for native JSON and semi-structured data processing. So that, if you have data that's sort of JSON formatted, I can run queries in something called particle query language, which is sort of an extension of SQL that allows us to deal with that sort of semi-structured data. So that's a new feature in preview. And then the other one is Redshift ML. So as a data warehouse user, I'm running queries or whatever, I can now create, train, and deploy machine learning models using SQL commands. So I don't have to say, take my data and then pull it into SageMaker or something. It's basically, using some of those features of SageMaker right inside Redshift. So like I said, that's bringing together the machine learning side of things here. Quicksight, I don't want to get too much into Quicksight. Here were the big things. It's a cloud-powered BI tool. Like I said, when it first came out, it was minimal viable product. They've added a lot of fancy features over time. One of the newest ones is this Quicksight Queue, which you've just got kind of a line. Like if you're looking at the dashboards and you don't see the data you want, you used to have to, as a business analyst or whatever, you'd go back and you'd say, hey, can you run me an ad hoc query and get me this info? Now, right there inside that dashboard, I can ask an English language question and it'll go and try and parse it using machine learning and figure out what's the answer based on that data that's in there. So if you want to know more about any of this, we have a few courses. These are official AWS courses. I think Michelle just put the link to our overall AWS page. You can find all these courses there. There's a 3-day class, Data Warehousing on AWS, that's really just 3 days on Redshift, right? From the development and design point of view, but also a little bit of administration. We've got a database class. It's a 3-day class just on databases, talks about running relational databases on EC2 versus RDS, and then all of our NoSQL options. It covers Redshift a bit. And then the big data class is one where we really get into EMR and Athena and Glue. And there's always the AWS Big Data blog, which is a good place to sort of keep abreast of all that stuff. That's really the content I wanted. I'm watching the chat. If you have any questions, throw them in the chat. In the meantime, maybe Michelle, you can tell us about this this promotion.
Yes, thank you, Miles, and thank you everyone for tuning in. I'm going to share a link in the chat window now because I know some of you may be on your way out, but we are running a limited time promotion right now, which can save you money on your training with us. Check out that link in the chat window to learn all of the details, but pretty much you can save up to $250 on your course, depending on the duration, and there's a few different modality choices for you to make there.
All right. So they have to register by January 29th, but they could take the course, in February, March, whatever, right?
That's right.
Okay, thank you. All right. Well, like I said, if we just kind of pop back here, these courses typically require you to know a little bit about AWS. I would say for the big data or the planning and designing, you should have taken sort of an associate level class like the architecting or the developing or the sysops. I think the data warehouse class, you could probably get by with just a 1-day like tech essentials class. As long as you've used AWS, you're familiar with the management console, you know what an EC2 instance is, then you could probably jump right into the data warehousing class. But these other ones are sort of advanced classes. They expect you to know a little bit about AWS. All right. Well, I think that's about it. You know what? I'm going to throw my email address here in the. If you have any questions, it's miles.brown@techdata.com. So I'll just throw that in the chat if you want to grab it and copy it. I just realized I didn't put it anywhere in the presentation. Like Michelle said, you should be sent a recording of the presentation and maybe also a PDF of my slides so you can use those links to click through and find those the announcements as they came along. And I'm going to stick around for a little while. If there's any questions, you can throw them in the chat. So far, not a lot of questions. I went through a lot of, new announcements pretty quickly. But like I said, I'm going to stick around for a little while in case anybody has any other questions.
Otherwise, thank you everyone for being here today. I'm going to stop our recording now and we'll be in touch soon.